Okay, this is a project overview for a data pipeline built using Azure Databricks. Um, a little bit about just disclaimer about the project structure. This is sort of a experimental project structure that has both uses the Matrin package to have both Python code, but also Rust code that can be wrapped and called in Python notebooks. That it wasn't implemented for this project, but it sort of explains maybe the confusing project design. That's why you see some cargo things in here. Um, the project architecture here. So what we're going to be doing is web scraping Steam reviews from directly from the website, loading those into the Databricks file store as sort of an archive, performing some transform and load operations into a Delta table, and then producing some visualizations from the Delta table. And all of this will be in an Azure workflow and linked to a GitHub repository as sort of a backup. Uh, Going into the actual Azure workspace, which is linked to the repo, we can see here. This is the same file structure as the repo, and going into our Python section where all our notebooks are, we see we've got the web scrape, the visualize, and the transform and load. For the web scrape itself, it's a fairly simple web scraper, pulls JSON format of all the reviews. In this instance, we're doing a demo of No Man's Sky, and we're getting 1,000 positive, 1,000 negative reviews. These are the most recent reviews to sort of highlight that this would be dynamic and continually done. Um, what this does is it puts it into a data frame and then writes it to a Parquet file in Databricks file store. And we can see that if we browse DBFS, we can see the Parquet file. That's sort of an archive and can be kind of added to if you wanted to be storing lots of reviews over time. Going back to the files themselves, um, we then have a transform and load. What that does is going to be part of kind of a larger project. So we're not doing too much data transformations. We're just taking the columns that we want using Spark SQL. And so we're just selecting those columns and writing that to a Delta table because those are the ones that we're going to do some analysis on. And then our visualize script pulls from that table back to a data frame, drops into the Seaborn package for Python, and produces some nice visualizations. And then in the workflow itself, we can sort of see we have our workflow. This sort of visualization, it failed a few times, but it shows you the progress of each individual task and then sort of the overall runtime. And you have a visual depiction of that workflow as well, with scheduling options for cron scheduling if you were to want to pull reviews every so often. If there was, you just released a game and you're getting a lot of reviews, you may want to pull that intermittently so that you kind of get live updates. So going back to what that visualization looks like, it writes this PNG file back to our repository. And this is actually a depiction of the Steam-defined weighted score for a review versus the user score, user-defined, like how many times a user upvotes. And we sort of see that there's actually an inverse and sort of, logistic relationship between those. And so this sort of, I guess, the recommendation we would provide here is that it seems that Steam's method for weighting reviews is in contrast to the way that users define helpful reviews. And so they may want to take a look at that. So this is the full kind of end-to-end pipeline from raw data to visualized insights.